we're going to add force vectors, and we're just going to review what we did in Unit 3, because here in Unit 5, we're going to be adding vectors that are at different angles and so on. So what I'd like to do is review all this by doing problem number 1. So let's do problem 1. So given, well, let's see, in problem number 1, we said F1 is equal to 3 newtons in the x direction and 4 newtons in the y direction. Okay, and then F2 is equal to 12 newtons in the x direction and 7 newtons in the y direction. What is it that we want to find? Well, we want to add the forces together. We're going to call that the resultant force vector. I'm going to call that F sub r, the result of adding F1 and F2. And I want all answers here in polar coordinates. And I didn't put that in the directions, and I should have. All answers in polar coordinates. So let's solve it. Well, when you add vectors, you just go F1 plus F2. 3 newtons, 7 newtons, 12 newtons. Oh wait, this should be 4, sorry. This is 7 newtons. So line them up like this and then say, hey, are these in rectangular coordinates or polar coordinates? These are in rectangular coordinates. So I can just add them up right away. In other words, I'm pushing with a force of 3 newtons in the x and 12 newtons in the x from F2. Both F1 and F2 they're both pushing in the x direction with a total force of 15 newtons. And in the y direction, I'm pushing up with 4 newtons from F1 and up with 7 newtons from F2. So that means I've got 11 newtons of force in the y direction. So there's FR right away. Now that is my answer in rectangular coordinates, but I want them in polar coordinates. So the magnitude of FR is going to be equal to the square root of the x component squared plus 11 newtons squared. And I know some of you are working this, and I don't have somebody borrowed my calculator, so if somebody could give me the answer here. Let's see, it should be, I don't know, around 18, 19, something like that. 18 point what? 18.6. And then let's do theta is the inverse tangent of the y component divided by the x component. Do I need to add 180 to this? No, I don't need to add 180 degrees because my x component is positive. And so what do I get? See, 11 divided by 15 should be, I don't know, about 35 degrees, 40 degrees, something like that. 36.3. Now what am I, a human calculator? How do I do that? 36.3 degrees? You agree with that? So we can say F sub r is 18.6 newtons of force at an angle of 36.3 degrees, and that's my answer. Now, I would like to draw a sketch just to make sure that this makes sense, that I didn't make a calculator mistake, that I didn't leave my calculator in radians accidentally. So how do I do that? So watch F1. I go over 3 and up 4. So over 3, up 4. So I'm going to make that F1. And then F2 starts where F1 ended up, right? When I add vectors, I'm hooking them up head to tail. So I go 12 newtons to, so if this is 3, then 12 would be way over here, and then up 7. And this is just kind of an estimate. So there's F2. So my resultant vector looks like this. There's FR. Starts where F1 started, ends where F2 ended. And does that make sense? Yeah, this looks like it's about, if this is, yeah, and then that angle looks a little bit more than 30. Now remember, this is just a little hand sketch, but it does confirm that what I got mathematically makes sense. And if you're ever a working engineer or even as somebody in business, it's good to have some way of checking your answers and making sure that your answers make sense, that you're not making some silly calculator or computer error. But that looks good to me. Any questions?